Hello, folks, our 98th installment. We're into the second half now of your Unit 9. So this second half of the unit is about scale modeling. It's a little longer than the first half, so it's not really a half. It's more like, I don't know, 6/9 or something, 6/10, I don't know. But we're modeling 2D objects to scale in the first bit. So let's get down to the scale factor stuff, what we're going to talk about first, and then determining unknown dimensions in a 2D modeling situation. The unknown dimension. Sounds like a movie. Okay. So first thing we're going to define is scale factor. In scale factor, we usually annotate or denote with a K. And scale factor is basically if I take an enlargement or a shrinking of an object from the original down to the image, the scale factor is what we get when we take a diagram measurement divided by an actual measurement. So a measurement on the image divided by a measurement on the original, but it has to be a linear measurement, okay? And that's very important. In some textbooks and in some places in your life, you may come across this as being called a linear scale factor. But every time we say scale factor in this course, we mean linear scale factor. Okay, so all we have to do is pick one dimension on one of these triangles. So let's take this one on the original. And I'd say that that's 5 units or 5 blocks long. Then I pick the corresponding one on what we hope is a similar image. It has to be a similar image. And that one's 3 units long. So we've got a 5 and we've got a 3. So then to find my scale factor, K, I take the measurement from the image and I divide by the measurement from the original. So I get a scale factor of 3/5. Okay? Usually we write it as a fraction. You could also say the scale factor is 3 to 5. Okay? You could say it that way. Or if you really want it, and very rarely do you see this, but you could write that as a decimal, a scale factor of 0.6. Okay? Most common way to see it is either this one or as a ratio like that. Let's see what else we got. A couple of problems now. A blueprint for a building is drawn with a scale factor of 1 to 32. The building is 48 feet wide. How wide is the corresponding dimension on the blueprint in inches? Okay, so remember that our scale factor K was a measurement from the image over the actual, okay? And that's just me rereading the formula that we had over here. It's image over actual for scale factor. Okay, we want the dimension on the blueprint, so that's actually on the image. So if we cross multiply this simple little equation here, what we get is our measurement on the image is just K multiplied by the actual. We don't usually work that out every time. We just sort of assume that that's common knowledge. So if you want to remember it that way. Okay, so our scale factor was 1 to 32, or 1 over 32, which is a more practical way to use it. And the building is 48 feet wide, so we've got 48 here. What are we going to get on the blueprint? So 1 over 32 times 48 is going to be a nice number to work out because it's exactly 1.5. So we've got 1.5 feet on the blueprint. But the question said, how long is that in inches? Okay, so in inches, we've got 1.5 feet, and it's not a hard one to do in your head, but let's show you the unit analysis anyway. Multiplied by, remember, there's 12 inches from grade 10 in each foot. So that's going to give us 1.5 times 12, and 1.5 feet is going to be 18 inches. Okay? So on the blueprint, that building would be 18 inches long. A regulation skating rink is about 60 meters long. On a scale diagram of a new rink, the length is 30 centimeters. What is the scale factor? Okay, so we're going from 60 on the original to 30 centimeters on the diagram or on the image. Let's get these in the same units so that when we calculate the scale factor, we're not going to get anything all mucked up here. So we're going to say that the actual has a length of 60 meters and that the image, and that's an easy conversion. We've been converting meters and centimeters since grade school. So 30 centimeters is, of course, 0.3 meters. Okay? So if we want to find our linear scale factor, k, we just take the image, 0.3 meters, and we divide by the actual, which is 60 meters. All right? Now you can get that as a decimal, but if I convert this to a nice fraction, we're going to like it a lot better, I promise. So I'm just going to multiply the top and the bottom of this scale factor by 10, so I get 3 over 600. Okay, see that nice and quick? And then they're both divisible by 3, so I'm just going to say 1 to 200 would be my scale factor. Okay, it's pretty straightforward, I think. Hope that's clear. So remember, scale factors are used to compare a scale diagram to the original it represents. The formula for scale factor is diagram measurement, or image, over actual measurement, original. To find a missing dimension, multiply by the scale factor. If the dimension is on the image, that's the one that we saw. And to determine the actual dimension based on the scale model, we divide by the scale factor. So if we want to find the measurement on the actual diagram given the measurement on the scale, we would divide by that scale factor. The scale factor formula can be used to calculate a scale factor given a similar dimension on both an image and its original. And we saw that in the last example that we did. Okay, so we just use that division to find the scale factor. And it's important to work in consistent units. Can't stress enough, important to work in consistent units or you're going to get your scale factors wrong. So anytime we make calculations, be wary of the dreaded units. Be careful, careful, careful. Okay, hopefully that's helpful. We'll do some more practice questions in the next section.